Hi guys, welcome back to the channel. So today we are going to be solving binary subarrays with a sum, and then we are going to be discussing three different approaches to solve this problem. So unlike the other videos, now we are going to be focusing on the question, and then from the question we are going to derive the three different approaches. So let's get into the question. Suppose we are given a array of nums, and then we are also given integer goal, and then we need to return the number of non-empty subarrays with the sum goal. Suppose let's say we take this example. For the subarray to exist, we need to have two different things. One is starting point and other is end point. So these are the two different points which we need so that we can get one particular subarray. Suppose let's say this is the subarray I want. That means it needs to have a starting point and then it needs to have a ending point. That means we need to choose two different places in indexes, that is I, and then there is going to be one more j. J will store the endpoint and then I will store the starting point. And then from these arrays, we need to find the sum. That means we need to calculate the sum from I to j. So this is going to be one more for loop so that we can calculate the sum from I to j. And then whenever we meet with the sum equal to goal, then we can we can increment the answer, and then at last we are going to return the answer. So in this particular approach, we are doing the for loop for 3 times. That means it is going to take big O of n cube as a time complexity. So we need to optimize it better. So can we remove this particular for loop? Suppose let's say instead of calculating the sum from I to j, let us consider, can we get the sum from I to j like here to here without calculating the sum. Suppose let's calculate the prefix sum, which is going to be like, in this it is going to be 1 and then again 1 and then again 2 and then 2 and then at last it is going to be 3. So now whenever we want the subarray sum, for this particular case we are going to take prefix sum of right endpoint, and then we are going to minus this particular prefix sum of I minus 1, so that we will get the sum of only this. So that is going to be the approach. At first we are going to make a prefix array, and then from that we are going to use this particular, we are going to remove this, and then we are going to use it as like prefix sum of j minus prefix sum of I minus 1. So we are going to take care of this. I minus 1 should not be negative. So we will be taking care of that. So we had reduced big O of n cube to big O of n square. So can we do in a better way? Suppose let's say we need a goal. So for this we are going to have prefix sum. That means it is going to have two different prefix sums, which is prefix sum of endpoint. So this is going to be the prefix sum of endpoint, and then in this prefix sum of endpoint we might need uh, only this particular sum and not this one. That means we need to remove some sum from the prefix sum so that we'll get the goal. That means this is going to be some prefix sum of some point, and then there will be a goal. So this is what we want, but we don't know what is the prefix sum which we want to remove so that we'll get the goal. So that is going to be, we'll be removing here, and then whatever the prefix sum of endpoint we are going to minus with the goal. Okay, now we got whatever the prefix sum which we want at some particular point. Suppose let's say we want only 1 at this point. At this case, we have a prefix sum as 2. Now we need to remove 2 minus, let's say, goal as 1, and then for this we need to remove one goal, so it is going to be, the prefix point is going to be 1. That means we need to remove this particular case. And then other than this, what is the another case? We can remove 1 0 as well. So it can be two different ways. So whenever we have prefix point, we'll have that particular prefix, but we need to count the number of times that prefix sum has occurred, that we are going to store in map. So this will store in map, so that it will count the number of times this prefix sum has occurred. And what is this? This is going to be some point which we want to remove, that we are going to calculate like prefix sum of endpoint minus goal. And then this is the map which we are going to use, so that we'll get the answer. So for this particular case, it is going to be big of n for the time complexity, and then big of n for the space complexity. So let's go through the code. So for this case, we are taking answer equal to 0, and then we are taking the map which is unordered map, and then we are marking mp of 0 is going to be 1. Why? Because let's say we start from starting. We can start from starting, and then let's say we will have element next as 1. That means we have the starting point which is going to be like negative, which will have zero sum. So we can remove that zero sum, and then we'll get the particular sum which we want. So that's why we are making map of 0 is going to be 1, and then this sum is going to store the prefix sum. So this is going to be the prefix sum. Now I need to know the number of subarrays which will have sum minus goal as my prefix sum, so that I'll get goal as my answer, and then this is going to be the sum. So let me give an example. Suppose let's say I have at this particular point. At this particular point, what is the prefix sum? It is going to be 2. Now I need to remove 1 such that I'll get these two as my elements. That means it is going to, let's say prefix sum is going to be, for this one it is going to be 1, and then for this one it is going to be 1. So mp of 1 is going to be 2. Why? Because it has prefix sum 1 as here, and then prefix sum 1 as here. So it is going to have count as 2. Now at this particular point, I am going to say number of subarrays with the goal as 1 is going to be 2, which ends at this particular point. So that is what I am storing, like number of times it has occurred sum minus goal. And then at last I am going to say this is the prefix sum. Whenever we meet this particular sum at the next point, we are going to use this number of times it had occurred. So we are going to store in the map, and then at last we are going to return the answer. So this is one of the approach where we can use the map, and then we can solve this. So let us consider one more approach. So we got map using this particular case where we had derived from the question. So from this we had derived this particular solution where we have map and everything. And then let me consider one more approach. Suppose let's say I have this particular case. Now I want goal. My main aim is to get a goal. Let us forget about the array and everything. Now I need a goal. Like I need to achieve this goal no matter what. For this case, let's say there is going to be 1, and then 2, and then till it is going to be goal minus 1, and then at some particular point I'll have goal, and then I'll have goal plus 1, and then till some particular end. Okay, this is going to be the distribution. Now I need this particular goal. So for this particular goal to get, I can to get the goal, I can do the number of goals which I can get. And one more thing is, suppose let's say we can consider at least and at most. Suppose let me consider at least. At least means it can have at least goal as my sum, and it can be at very end. Now if I consider this case, it is going to be considered from goal and then till end, whatever the sum it might be. Now to get for only goal, we need to remove all these cases, which will have at least goal plus 1. So at least we can at least of goal will take that as one particular answer, and then from that answer we are going to remove at least of goal plus 1, so that we'll get the goal. And then let us consider in terms of utmost. Utmost means it can have utmost sum as goal, and it can have below than that, and it cannot go more than that. Suppose if I consider utmost as goal, then it is going to be these are the sums which I am going to consider. So to get to only sum as goal, then I need to remove this is the this is the total. Now I need to remove utmost goal of minus 1, so that I'll get only the goal. So that is going to be our approach for this. Suppose let's say, yeah, now we got like utmost utmost of goal minus utmost of goal minus 1. So this is going to be our solution. Now we need to find what are the different number of subarrays with the utmost sum as goal. That is what we need to do the solution. So for this case, if we consider, we need this particular goal. Okay. Now it can be 0, it can be 1, it can be 2, it can be 3, and then it can be 4, it can be 5, and then it can be 6. Now let me consider that I need only one as my answer. Let me consider 3. Now whenever I see like this particular end where I'll have 3. Now for the 3, I need the answer as, suppose let's see the solution. So now let us consider this particular case, num subarray with the sum. Now we are going to say maximum sum we can get is goal, and it can have different number of subarrays. So for this we have goal, and then the other case will be goal minus 1. And then let's say the goal minus 1 is negative, then we cannot have this particular case. Why? Because there are no elements which will be like negative value, so we are going to return 0. And then one more thing is, we are going to consider left pointer and then right pointer, and then we are going to have sum, and then we are going to have answer. Now we'll be having the prefix sum, which is going to calculate the sum of this particular case. Suppose let's say we have sum less than or equal to goal. That means we can have all the subarrays which ends at this particular point. It is going to be considered as valid subarray. What do I mean by that? Suppose let's say this is where we are. Let us consider this. Suppose let's say this is 2. Now I need goal as 2. Goal as 2. Now I am present here. That means sum is less than or equal to goal. That means whatever the subarrays we can derive by keeping endpoint as 2, it is going to be valid. Why? Suppose let's say I consider this particular case, then it is going to be sum will be less than 2. Why? Because we are considering only some sub elements of total array. And then let me consider whole array, then it is going to be less than or equal to sum. Why? Because it will have equal sum as whole array. And then if I consider only 2, then also it is going to be less than or equal to sum. That means whenever we have array with the sum less than or equal to goal, then all the subarrays which ends at this particular point is going to be considered with the answer. So for this so what are the number of arrays for this particular end? So for this particular end, we can choose the starting point as same end. So this is going to be one array, and then we are going to consider starting point as here. Then it is going to be two arrays, and then we can choose the starting point as here. Then it is going to be three arrays, which ends at this particular point. So this is going to be 3. That means whenever we have j as here and then I as here, then we are going to say j minus I plus 1 is going to be the answer, which we are going to add it to the answer. So that is a case. Suppose let's say, while, and one more case, suppose let's say we have 3 and then we want only goal as 2. Now we need to reduce the starting point from here. Now we have 3 here and then we need to reduce this particular 3. That means we need to remove 1. So that we'll get back to here, and then from this particular point, whatever the array you consider, like from here to here, or here to here, or here to here, or from here to here, then the value, the sum of the values is going to be always less than or equal to 2. That means we can add it into the answer. Whenever we meet such particular case where we have sum greater than goal, then we are going to reduce the sum by moving the left pointer to the right. That means we are going to move this left to the right, and then we are going to reduce this particular sum. And then whenever we come out of this loop, then it is going to be sum is always less than or equal to goal. That means we can add all the possible arrays, which is going to be right minus left plus 1, and then we are going to increment the right, and then at last we are going to return the answer. For this particular case, if we consider time and space complexity, the time complexity is going to be big O of n, and then the space complexity is going to be big O of 1. Why? Because we are not considering any extra space. Yeah, that's all for this video. Thanks for watching the video. Bye.